a spherometer. It is also a measuring device. Let us see how to use it to find the radius of curvature of this convex surface. So we have already found the least count of this apparatus in our earlier video. We have found the least count of the spherometer like this. That came out to be 0.001 centimeter. Now this A is the distance between the legs. So what we have done is we have placed this on this and pressed it against like this, and we have measured the distance between those legs. We have pressed the legs and we have marked those points like this. We marked them and we measured the distance between the points like this. We found out that the distances between the legs are 4, 4.2 and 4.2. So the mean comes out to be 4.13. That means the distance between the fixed legs on an average is 4.13. That is small a. Now let us measure for the plane mirror or the plane surface. So let us put it on a plane surface. So we have taken this plane surface. We will place the spherometer on this plane surface and slowly move the movable leg down such that all the legs, all the 4 legs are touching the surface. Now see, we will use this paper to check whether all the legs are touching the surface. It should not topple down. See, the center leg also, the paper piece is not passing. That shows all the 4 legs are exactly on the surface. After keeping it on the surface, we are going to measure the main scale and the circular scale reading. The main scale reading is taken here. This is the main scale. Now, while taking the main scale reading, we will consider this lower 10 as 0 and this 0 as 10 mm or 1 centimeter and this 10 as 20 mm or 2 centimeter. So the circular scale is touching here a little below 0. We will see exact. And this circular scale reading is on the circular scale. Let us take those readings. So as we see, the main scale reading is 0.9 centimeters or 9 mm. Let us see the circular scale reading. The circular scale reading is taken here. And as we can see, the main scale is touching on 11. So the circular scale division is 11. So let us write it down. So for the plane mirror or the plane surface, the main scale reading is 0.9 centimeter. And the circular scale division is 11 division, the coinciding division. So the CSR, this is the CSR. It is similar to your micrometer screw gauge. This is MSR. So the circular scale reading is 11 into 0.001. That's the least count. So this is multiplication. So that is equal to 11 into 0.001, which is 0.011. So the total reading is MSR plus CSR. So that is 0.911. Now let us take another reading. So we again place it on the plane surface, but at a different place. Suppose we keep the distance here, and again repeat the process whether it's moving or not. So this should not go from here, and we will take the reading again. So disturb it and again place it down and see whether it is moving and take the reading. So now the reading is 0.9 and 5. So let's write it down. So the mean comes out to be 0.908. Now let us take the convex surface. So we take the convex surface and place this on this. Now purposely we have marked these lines so that we get the approximate center. So this is curved like this. So this is convex surface, whereas this one is a concave. So we will take convex over here. You can take for concave also in a similar manner. So now if you have taken the convex surface, now place this on this at the center. So obviously the previous position, this is going to topple like this. So we have to pull the movable leg up. So let us raise it up and again check with that same paper whether the paper is passing from all the 4 legs or not. It's still passing, as you can see. So let's raise it a bit and again check. So we'll put it down and check whether the paper is not passing from each one of them. So now it's all right. Again we are going to take the reading of the main scale and the circular scale. Now look at the reading. Look at the main scale. It has risen up. Now it is 1 centimeter. 0 is 1 centimeter or 10 mm I told you. So that is 1 centimeter. And similarly you'll take the circular scale reading here. So let us take that, write down that reading. So the main scale is 1. The circular scale reading is 91. So let's write it down. So the main scale reading is 1 and the circular scale reading is 91. So this comes out to be 0.091 and this comes out to be 1.091. Now we have to take a second reading. Now the second reading, mind well, it should be at the center itself. That means, suppose we feel that this is not the center, a little here will make it the center. So at the center only, let us take another reading. So again we will allow this to pass. If it is passing, so let us make it a little lower. Now it no longer passes. Check the other 4 again. So it's not passing through all the 4. And now we will take the reading again. Again the main scale and the circular scale read. As we can see, the main scale reading is again 1 and the circular scale reading is 86. So let us write that down. So the main scale reading is again 1 and this is 86. So let us multiply and then write the mean. So we have got the second reading as is 1.0 and 86. So the reading comes out to be 1.086 and when we take the mean it is 1.0885. Now that is y. So you have an x reading and a y reading. So we are going to subtract the two to get something known as the sagitta. So sagitta of the spherical surface is h, which is x minus y. Actually, what is the sagitta? There is a space between the convex surface and the plane surface. That distance is called sagitta. So this spherometer does not measure the radius of curvature directly, but it measures how much the convex lens is raised up the plane surface. The difference. So spherometer measures the difference in their the heights. So that is called sagitta. So let's find the sagitta of the spherical surface. So the sagitta of the spherical surface is x minus y, it is modulus. Our y is greater than x, obviously, because it has been raised up. Had we taken a concave surface, this reading would have been lower. So the difference comes out to be the subtraction of the two, and that is 0.1805. If you minus these two, you get this. Now we have got the radius of curvature formula. R is equal to, the radius of curvature is equal to a square. A square is this a square, which is, we had found the mean between the fixed legs, that a. So we will put that a value upon 6 into h is nothing but the sagitta plus h upon 2. So let's write it down. So we substitute it in the formula and we get it somewhere around 15.84 centimeter. That's the radius of curvature of this surface. So using the spherometer, we have found the radius of curvature indirectly by finding the sagitta. So that's all. Next time we are also going to see how to do log calculations.